Hi everyone, this is Chef Jin Academy. Welcome to one of our awesome tutorial. In today's video, I want to show you how you can design base plate connection using Prokon and STAAD.Pro software. So the connection design is going to be done on Prokon, but we are going to be using STAAD.Pro software for obtaining our design loads such as the axial load, shear force along the X and Z, and the moment in case there is movement. So the video is divided into 4 sections on the program software. So we'll be diving into each of these sections and we'll be showing you how you can do the design and also how to generate your connection detailing. Also, after getting the connection detailing, how to export your detailing to Autocad for editing. If this is your first time on this channel, make sure you subscribe to the channel, likes the video, and comment in the comment section in case you have any question about the video or about any other video on my channel. Let's dive into it. Hi, welcome back. So this section of this video is divided into 4. We have the layouts. In the layouts, you are going to get the geometry of our steel section, the information about the columns, information about the short columns, the concrete column in which the base plate will be resting on, and the geometry of the bolts for the connection design. After obtaining the layout, then we move to the loadings. So in this case, we'll be using the STAAD.Pro software. We go to the STAAD.Pro, we have an already analyzed structure. So we generate the forces and stresses on the structure that we are going to use on our connection design software. Then we get to the design part. The software is going to run the design for you, so it's very easy. After that, you have the output. With the output, you are going to generate the calculation sheet and also the connection detailing. And with this output, you can export your detailing to Autocad, as I've explained earlier. So see you in that phase. This is the Prokon interface. If you don't have the software, I will leave the link in the description of this video. Then from the link, you can download the software. Then there is also a video on the looking at the top right corner of this video. You see a link where you are going to install the software. I'm going to put the link for you to do that. Then the first thing we like to do is you come to the base plate design. Click on base plate design. Then once the software loads, you have this interface. So the first thing you want to do is to change your design code. You come to the top left corner here, click on it, then you see practice code. So you can change your design code, click on it. So on Prokon, you have varieties of code, but the ones that you can use for connection design is the Euro code and the SAN. So in my own case, I'm going to choose Euro code. Then you can save it as your preference settings if you like. Then you click OK. So now we are on the layer tab. That is, we want to select the geometry of our design. So the first thing is the material properties. So this is the property of the concrete where you want your base plate to rest on, the short concrete. So the first thing is the FCU. So we are going to use FCU of 20. So for the strength, this is a steel plate. So you use the strength of so this strength is talking about the strength of your of the plate. That is the strength of the base plate. So because the base plate is made up of steel, so we have 3 categories of steel strength. We have 3 categories of steel grade. We have the S275, S355, and S460. So in our own case, we use S275. Then this F ultimate, this one is the according to the design. If you are designing based on the Euro code or the BS code, the ultimate, the type of strength, the ultimate strength, we have 3 grades of strength. So the ultimate strength depends on the thickness of the plate. So if the thickness of the plate is less than 16 mm and you are using a grade of 275, so that means your ultimate strength is 275 and your steel strength FY is also 275. But if it is less, you can go through the code and pick the the one to use. Then you have the FY. This is the strength of the reinforced concrete column. So in this case, you use 410. Then the FU also 410. Then this is the strength of the weld. This is the strength of the weld. So we can just use something like 200. Then this is the grade of your bolt. We have different type of bolt. We have 4.6 bolt, we have 8.8 bolt. So in this case, we use 8 bolt of 8.8 grade. So moving to the section, the column section. On the column section, you have what we call, this is where you pick the section of your column, your steel column. So if you used a UB section, this is an H section. You come to H section, then you can pick the necessary section. So 254 by 254 by 73. So let's use this. Click OK. So this is our section. Then as you can see, once you're editing all these parameters, you have some changes on at the right corner here, the diagrammatic representation. Then after selecting the column, you have the base plate. So here is where you select the geometry of your base plate. You can click on select. Then in this section, you have two forms. You can have a circular base plate. You can have rectangular base plate. The most commonly used one, when you have a 8-section column, then you should use a rectangular base plate. But when your section is a pipe section or a circular section, then you can use a circular base plate. So in our own case, we use a rectangular base plate. So we let the dimension to be along the height to be 400 and the other one to be 500. So this is if there is an offset for your base plate. If you have an offset for your base plate, you put in the offset. But in our own case, we don't have any offset. The steel column is going to be centralized. Then you click OK when you are done. Then the thickness of the plates. In this case, you pick the thickness of the plate. So let's just go with 20 mm as thickness of our plate. Then you now come to the concrete support. So this concrete support must be wider than your base plate. You know, our base plate you use 400 by 400 by 500. So in this case, you can use something like 500 by 600 so that it is a little bit wider than the base plate. So if you are using a circular base plate, you have to use this. You can place it on a circular concrete base, but it's better if you are using a rectangular base plate, place it on a rectangular concrete base. So in my own case, I will have to use 550 by 600 as my concrete base. Then if there is offset, in my own case, we assume it is centralized. Then you click OK. Then once you're done, then the next thing is the stiffeners. Stiffeners are very important. So you can come to select, then you pick any type of stiffeners that you want. So this is the chamfer for those stiffeners. This is the first stiffener. This one is when you are not using any stiffener. The second option is where you just want to use just a single stiffener. Then this one is when you want to use 2 roll of stiffeners. This one you want to use stiffeners along the X and Y, but they will be attached to the outskirts of the column section. So the same thing goes for this. So but in our own case, we assume that there's no much load, so we are not using any stiffener. So you click OK. Then you now talk about the bolts. You need to now pick the type of bolt you want and the layout. So you come to select, then you can pick circular or rectangular. I think we quite understand this. If you are using a circular base plate, you pick circular. If you are using a rectangular base plate, you pick rectangular arrangement. So you now have the number of rows and the number of columns. So in this case, I'm going to use 2 rows, 2 columns. So but for the spacing of my rows, you know, my base plate was 400 by 400. So I want, according to the code, there must be a minimum spacing between the two. So in this case, I'm going to put 250 as my spacing here. Then, okay, let me put something like, you see, so that it come out of this place, it's come outside a little bit, 300. Then in this place let me put 400. So you can now see how the arrangement is arranged. Or you can use 250. When you run the design, if there is need for you to make any changes, you know. Then you click OK. Then the diameter of the bolt. The diameter of the bolt, we have 20 mm bolt, 16 mm bolt, M20, M16, M20, M24. Those are the common ones. So let's stick with M24 bolt, M20 bolt. Then the end type. This end type is how you want your bolt to be. Is it a circular one? Is it a squared one? If you can use this to rotate this about, you can use this side here to rotate it around. So in this case, I just use a square plate. Then the anchor length. This anchor length is how your anchorage, how it's going to enter into the depth in which it's going to enter into the short column. So in my own case, let me just put something like 900 mm. So once I put 900 mm, when you rotate it like this, okay, let's rotate up and down like this. So you see, then the base plate width, the end plate width, the width of this end plate, that is okay, end plate here, this plate here, its width. So let's use something like 50 mm. Then you have the thickness of the end plate, 20 mm as the thickness. So this is the end plate of the stuff. So if I change it to circular, you can see this area here change to circular. So if I change it to squared, so let me just use a squared. If you want stored end plate, that is, you remove that end plate part, the end plate, the width, so that you don't have any end plate. So that is that. Let me just use a squared one. You have that. So since you are using a bolt of okay, 2020, then this with the wedge size, so you can use a wedge size of 10 mm. So now we are done with the layout part. So this is the second phase of the video. So we're done with the layout. The next thing is the loading. So we come to our STAAD.Pro software. So this is the STAAD.Pro software. This is the structure we are talking about. So you want to design the connection between each of these columns with the base plate. So what we are going to do is we are going to pick the maximum column, the column that has the maximum effect. So this structure has been analyzed. So you just come to post analysis and you come to reactions. So under reactions, you see the different loadings. So you can just come to summary and you pick the maximum load. You can see this is the maximum load. You can just click on it. So once you click on it, so you know. So but looking at it, this member here, this second member here has the maximum effect. So it acts an axial load of 123.5. Let's just say 123.5, and shear force along the X and Y. Actually, I'm working with the ultimate load. You can change it if you want the serviceability load. You see, it also has the same thing, either the service or the ultimate. So you can, to see it quite well, you can come to beams. You know, we already know the columns that has the highest effect, which is this column. Come to beam, then you come to graph. Then here, just click on it. Then you can see this is the moment at the top. The moment at the bottom is 0. Then because we have the reason why it is 0 is because the support is a pin support. You can come back to node and pick reactions. So this is what we need. We need the fx, we need the fy, and this is the z. So these are the loadings that we need. So fx is 20 points, let's say 20.1, fy is 123.5, and z is this. Then based on the service load, we can also pick is still this one. So since we've known our loadings that is coming on the foundation, we can now design the base plate. So we're coming back to this. So we now move to the load tab. So once you move to the load tab, you see you have load cases, you have P, you have torsion, you have shear force along the X, moment along the X, shear force along the Z, and the factor. So let's say load case 1, we have two load case, the ultimate load and the service load. So the ultimate load is load 1, the service load is load 2. So the shear force there in this case is 123.1. We don't have any torsion, put 0. The shear force along, sorry, this is the axial load. As you can, let me change this like this. Okay, you can see the representation how the load is being applied. So this is the axial load. Then the shear force along the Z, it was 20. We said 20.1. Then there's no moment because the support was fixed. Then the shear force along the Z was 0.005. 0.005, and this is 0. Then because we have already factored this load, so we can take it as a factor of 1 so that there is no need for us to factor it again. Then for the ultimate load, for the service load, you just pick, we have 13, 8, 84, and minus 0.4. So you can just come here, 84, let's just say 85, this is 0, this is 13, let's just say 14, this is 0 as well, and this is minus 0.004, this is 0 as well, and then you have 1 as a factor. So we've done with the loading. So that is how to put your load on the software. I hope you get. So now you have to pick a load for the design. You have to pick a load for the design, even though you can generate a calculation sheet in such a way that it will design for both load cases, but just pick the ultimate load, the one that you know is the most crucial. So the next thing is now to move to the design phase. So now that we've defined the load that we obtained from STAAD.Pro software, so we now move to the design tab. Click on the design tab. Then what you just have to do is you just have to click on, you can see that the load case that we picked is the one that was active. So you just click on start. So once you click on start, then it's going to run the analysis. So you can see the axial load on each, the shear force on each boat. If you zoom to the boat, you can see the shear force on each boat and the loads on each boat. Then you can also click on the strains if you want to see the strains. The only result you can see on Prokon is stress and the strain. So you can click on the strain, then to show you the strain in a diagrammatic form. The stress is in blue, the strain is in green. Before we move to the output, that is where we are going to generate our calculation sheets and our detailed drawings. For you to check if your design failed or not, if you come to this side, you see there is no display of anything like stresses. So let me show you something so that you know your calculations failed. So when the base plates, when any of these change to red, it means it fails. Let me show you something. So let's come back to load. Then let me change my axial load to 10,000. Let me increase it. Then come back to design. Then start design. So what do you see? You see that the base plates change to red, meaning the concrete fail and the wet fail. I hope you understand. So that's how to check if your design is okay or not. So in our own case, our design is okay. Come into design and click on start. We don't have any error. So the base plate is in blue and the concrete is also in blue. So that means there is no error. The design passed. So if there's any error, you can go back to your geometry and change maybe the arrangement of your boat. You can increase the number of boats, you can reduce the spacing and all that. So we now move to the output section. Welcome back. So in the to get to the output section, just click on output. Then you can see your calculation sheets. You can just go through your calculation sheets. So let me show you where the design started from. So this is where the design starts from. Calculation sheet for load case 1. So these are your loadings. Then you can go through all the shear in both the factor of concrete and the weld and all that. So you can print your calculation sheet by clicking on print. Then you click on OK. Then we ask you to select where you want to print your project. So I don't want to print, so I just cancel. So now to export or to generate your calculations, your shop drawings. So you come to shop drawings, then you can see your drawings. So these are the detail of your drawing. This is the boat, the length of the anchorage, and this is the plan view of the boat. Then the size of the hole, according to the code, if the boat size is 20, you should add an addition of to the hole of plus 2 mm. That's why the size of hole was 22. So here you can also print out your shop drawings as a PDF by printing it, or you can send it to PAD, that is to convert it to DXL file, or you can just come here, save picture as. So under this save picture as, you change your extension to DXL file. Then you can now rename it to anything you like. So let me just say example. Okay. Let me save it on desktop. Let me just say example 2. Example 2. Then you click save. Then from there, you can access the drawing on an AutoCAD file. So that is a simple way of designing your base plate connection on Prokon, and also checking your calculation sheet, also exporting your drawing saving your drawing as a DXL file and exporting it to AutoCAD. You can now open the DXL file on AutoCAD. Then from there, you can edit your detailing to suit your choice. So let's try and open our detailing on AutoCAD. So it is loading now on AutoCAD. So this is it. So this is your detailing. So this is how the detailing comes out. So you can just copy this one out. You can move it away, something like this. So you can just edit this detailing. You can add your concrete base to it. You can drag it down. We don't specify the depth of the concrete base, and the depth of the base should cover through this. So you can drag it down, then add additional informations that you think you should add to the detailing. So we'll be ending the class there. If you like this video, make sure you subscribe to the channel, then give me a comment in the comment section. See you next time. Bye.